The boiling points of halogens increase going down the group due to increased induced dipole-dipole interactions, or London forces as they are also known. These forces increase because the number of electrons increases as you move down the group.
Chlorine is added to drinking water in small amounts. The reason this is done is because chlorine is effective in killing waterborne bacteria. The potential drawbacks of adding chlorine to drinking water are that chlorine is toxic, and also there are concerns that chlorine might react with organic material to produce chlorinated hydrocarbons, which are cancer-causing. However, the danger from waterborne bacteria is far higher, and so overall, adding chlorine to water does make it safer to drink. When chlorine is added to drinking water, chloric 1 acid is produced along with hydrochloric acid. This is a so-called disproportionation reaction, which is where a species, in this case chlorine, has been simultaneously oxidized and reduced. The oxidation number of chlorine initially is 0. For chloric 1 acid, the oxygen will be -2 and the hydrogen +1, so the chlorine must be +1 to make the compound neutral overall. The hydrogen in HCl must be +1 and the chlorine in HCl must be -1. So the chlorine has been oxidized in going from an oxidation number of 0 to +1, and also reduced in going from an oxidation number of 0 to -1. Chlorine also disproportionates when it reacts with sodium hydroxide to form bleach. The presence of halide ions can be tested for by adding aqueous silver nitrate solution, which will produce precipitates if halides are present. The ionic equation for chloride ions reacting with silver nitrate is as follows. The equations for the other halides are similar. Chloride ions give a white precipitate, bromide ions give a cream precipitate, and iodide ions give a yellow precipitate. To confirm the presence of a particular halide, dilute aqueous ammonia is added. If the precipitate dissolves, this means chloride is present. If the precipitate does not dissolve with dilute aqueous ammonia, then concentrated aqueous ammonia is added. If the precipitate dissolves, then bromide is present. If the precipitate still fails to dissolve, then iodide ions are present.